Today we will be talking about geothermal energy. Geothermal energy is a very underutilized energy source, but it has a lot of potential. This is partly because there is a massive increase in energy demand expected within the next 20 years, and current popular non-renewable sources may be phased out. Current renewable sources can be costly, and it is unclear when those costs will come down. Furthermore, some of these renewable sources are limited by their region and location, making it hard for some places to take advantage of them. Geothermal energy has fewer regional limitations because it uses heat from the ground, which can often be found in many places. It is a renewable resource with low operational costs, although there are often high initial costs. There's a ton of potential for geothermal energy usage in the United States, as California is the main consumer, using 80% of the US's total geothermal production, and that only accounts for 7% of California's overall energy usage. Currently, under 20% of America's energy is renewable. A big question is what will happen to jobs in the non-renewable energy industry. However, those who dig for oil can repurpose their machines to dig for geothermal energy. Furthermore, there is a 4 million megawatt potential for geothermal energy in the United States per year, which is a lot more than the 3,300 megawatt production currently in the United States per year. This large amount would fulfill all the United States' energy production needs. For households, the geothermal energy heat pump produces energy by running cold water into the ground to make the water hot, which creates energy, and then the water is sent back down to restart the process. The opposite can be done to cool homes in the summer. For the more industrial setting, geothermal power plants use water from underground reservoirs and turn it to steam, which spins a turbine on a generator to create energy, and the steam is cooled back into water and returned to the ground to once again restart the process.
At Cornell, vast amounts of energy are required for energy-intensive research labs in addition to typical operations including heating and cooling. Most of the energy used at Cornell comes from natural gas, solar, and hydroelectric power. Limited oil and coal is used. To cool buildings during the summer months, lake source cooling is used. Lake source cooling is a comprehensive system to use the cool water from Lake Cayuga to cool campus. Cold water is pumped to a heat exchanger at the shore where it absorbs some of the heat in the water used to cool Cornell. Both of these loops are closed so no water from the lake comes in direct contact with the campus loop. After the water is cooled, the water from the lake is gradually dispersed back into the shallow waters. Cornell has put forth an ambitious goal of reaching carbon neutrality by 2035. Over recent years, emissions have decreased and carbon sinks have increased. In order to meet these goals, the university is exploring geothermal energy. Tompkins County and Cornell University are located in a region with favorable geothermal resources. This area has higher grade resources and has more potential to provide productive geothermal energy. To take advantage of this resource and sustainably heat campus, Cornell is working on a project called Earth Source Heat. This video created by the university explains how it works.
To heat buildings or generate electricity, Cornell scientists have studied large-scale geothermal systems around the world and are exploring ways to develop deep geothermal technology closer to home. Scientists will start by gathering data and studying rock formations beneath Cornell's AEM campus. Next, to reach the hottest rocks in our region, scientists would drill a 2 to 4 mile deep test well. The well will be safely enclosed with the highest quality casings, cement, and other materials to protect the environment. Only after successful research, safety precautions, community engagement, and other approvals would scientists drill a second well to complete the system. This would allow water to be slowly pumped into the earth where it would be naturally heated, pumped back to the surface, and circulated through buildings on campus. While this is an exciting project, it will take years of careful research and planning to implement. If successful, it will heat our entire campus and create a new renewable energy industry capable of sustainably meeting heating challenges throughout New York State and beyond.
To be clear, this project is still in the first step of research and development. Experts are working to find the optimal well locations to be used in this system. Using a techno-economic tool called geofires, they can simulate the long-term viability, energy supply, and investment needed for a location. In addition to this, researchers are attempting to measure the geophysical properties of reservoirs to model the impacts and effectiveness of specific locations. All this is in an effort to optimize the eventual well locations. If this project proves successful, this technology can be adopted across the Northeast, sustainably meeting heating demand using the natural heat of the Earth.